Okay, so let's consider another example here. Limit as x approaches pi over 2 from above of 1 plus tangent x over secant x. Okay, so very quickly, as x approaches pi over 2, remember cosine approaches 0. And we're doing this from the positive direction. So you may want to draw your little unit circle picture here. Might find that a little helpful. All right, so we're approaching pi over 2 from values that are bigger than pi over 2. So that actually means we're over here. And approaching it that way. Right? So values that are bigger than pi over 2. And so as we're doing that, cosine, of course, is 0. So tangent would be sine over cosine. Tangent would be sine over cosine. So sine's positive in the second quadrant, cosine's negative. So that's going to be a positive over a negative, and so that would actually be negative infinity. And in the bottom, secant is 1 over cosine. As cosine goes to 0, that's also a negative infinity. So we're actually dealing here with an infinity over infinity limit. Okay, so that's the first observation to make here, is that we are dealing with infinity over infinity. So we invoke L'Hopital's rule. Limit as x approaches pi over 2 from the right. Take the derivative at the top. That would be derivative of 1 is 0. Derivative of tangent is secant squared. And in the bottom, derivative of secant squared would be secant x tangent x. And we keep going. That would simplify to just secant x up top over tangent x. Now, if we try to apply L'Hopital's rule again, we run into a little bit of a problem. See, because this is still an infinity, secant pi over 2, which is going to be, as we go from the right, is going to be negative infinity again. And tangent of pi over 2, same thing. As we go to that, it's going to be negative infinity again. If we try to do this again, we run into a problem. Derivative of secant is just secant tangent. Derivative of tangent is secant squared. That's just going to be tangent over secant. And it's just going to keep being that over and over and over again. All right? So, yuck. All right, we have this infinite cycle if we just keep trying to do L'Hopital's rule, because it's just going to keep being secant over tangent, tangent over secant, secant over tangent, tangent over secant, right? Over and over and over and over again. So that doesn't work. We've got to try something else. So L'Hopital's rule kind of falls a little apart here. So what I'm going to do is take this thing and rewrite it. See if I can do some algebraic manipulating of this thing. To hopefully give us something we can work out. So here's what I do. Limit as x approaches pi over 2 from the right or above. Secant is 1 over cosine. Right? And then that's over tangent, so I can say divided by tangent. Remember, tangent is sine over cosine. Rewriting this. And then do a little bit of manipulating here. That'll be 1 over cosine. Remember, when we divide by a fraction, we multiply by its reciprocal. Now, as long as I haven't actually hit pi over 2, I can just cancel out those cosines, the top and bottom. Just cancel out those cosines. And now I have a limit as x approaches pi over 2 from above of just 1 over sine. And I can allow x to now be pi over 2 because the infinity over infinity is gone, right? I can allow it because sine is defined at pi over 2. And that's just going to be 1 over 1, which will just be 1. So sometimes you do have to invoke some other approach, right? L'Hopital's is not like the be-all, end-all. It's always going to work everything perfectly. Like I said, here we see this example with secant tangent where we would be stuck in this vicious cycle over and over and over again. But here we're able to work it out. Here we're able to work it out by, injecting hey, let's try something different. Let's try something different. See if I can simplify this sum first. And maybe make some progress that way. And that's actually how we're able to do it in this particular problem here.